Now this video is going to focus on the springs portion of the PowerPoint. The spring is basically anything that you put a load onto. You change its position or shape, let it go, and then it bounces back to its original shape. In spring design, there are three important things to consider. They're noted here. Number one, you have to use the least amount of material for your spring or volume, the least amount of volume. Number two, you're getting the desired spring rate. And number three, you're making the spring as small as possible so your other parts can fit in your design where you need them to. There are many types of springs. This slide shows 4 of them. The first one is a compression spring. It gets smaller and wants to expand. This is probably the most common spring. It can be used in a clicking pen or in a bed, among many other things. The next type of spring is an extension spring. This one gets longer and then wants to shorten when you loosen it. You can find this one on the inside of a screen door when you pull it closed, or around the outside of trampolines. Another type of spring is a leaf spring. This is just a piece of material that is deflected or changed shape and then it bounces back to its original size or shape. A good example of this is a diving board. The last one that is shown on this slide is a torsion spring. This spring has 2 pieces that stick out on either end, and when you try to bring those together, you can find those on hair clips or clipboards are good examples. The last 2 types are shown here. The first one is a clock spring. The one after that is a constant force spring. The constant force spring is inside of a tape measure. You basically pull it out, and when you let it go, it winds itself back up inside the box. The basic difference between these two is that a clock spring force varies, where a constant force spring force stays the same. It does this because the center in a clock spring stays stationary. It does not move. A constant force spring center moves with the spring. Here you can see the various materials that are in the spring. Okay, what you need to know here is that the most commonly used material is music wire. Okay, this slide tells you basically how the springs operate. Springs that have a larger wire diameter are stronger. If you make springs that are smaller in diameter, outside diameter, they are also stronger. Also, the more coils that you have, the less force that you need to move it. These next 2 slides are going to be used together to determine if your spring design is sufficient. You'll need to make sure as an engineer that when you design a spring that will not unravel, break, or seize. This is what these charts are used for. On this slide here, okay, you're going to find the usage chart. This tells you what type of usage you have. Anything that's going to be used a lot, like shocks on a car, should have a severe service. Anything that's not used a lot, like maybe a clipboard, could have a light service. Okay, basically you need to look at how many cycles you want the spring to have and then find which service is needed. Keep that in mind how it's shown. See this axis here, it's an exponential. So 10 to the 2 is 100 cycles, 10 to the 3 is 1,000 cycles, and so on. Basically 10 to the 7th would be a good way to say that it's going to last a very long time. Once you have the service level defined, you're going to go back to this chart here. Now this chart might be a little scary, but is not too bad to understand. The size of the spring wire is on the x-axis. The stress is on the y-axis. Now this is shown in KSI, so it means that it's in thousands of PSI. And the curves here are to guide you with the service level. Here is severe, here is average, and there is light. Basically, if you have 2 or 3 items, you can find the other. This goes for the spring wire size, the stress level, and the service level. So I'm going to show you how to use this chart. For a spring wire of 0.04 and a severe service level, okay, if you cross over, you'll see that you're only allowed to have 100 KSI of stress. Anything higher than that would be bad because it's above the curve. If you look at 110 KSI and an average service level, you go over here, you'll see that you're allowed to have a spring diameter size of 0.18. If you have a spring diameter size of 0.07 and you go up to 130 KSI, you're only allowed to have an average service level. You may need to rewind the video to hear that again. That way you can do the questions that will be given to you in your assignments. So you might need to rewind and pause that. Now, one thing to keep in mind is that the point that you want to use has to be between the curves, or it has to be below the curve for the service level that you want to use. So if you have something that goes between the average and light service, you're only allowed to use it for light service applications. If you have something that's over the light service curve, your spring will most likely fail and it needs to be redesigned. So that's something you'll have to keep in mind. Now, the last two slides that are in this PowerPoint, here and here, are going to review formulas for calculations for springs so you can determine the stress, load, and size of the spring. Now, I normally would have you guys create a spreadsheet with these equations in it, using these equations in it, but because we're online now, we're going to skip that part. If you want to create one for your own benefit, please feel free to do so.